Another feature of the Solidity programming language you should know about are events. So what are they? Well, Solidity lets you subscribe to events from an external consumer to find out anytime a function or something inside of a function has been called. So in this case, we have an event here that I've created called message updated. All right, this has some different arguments or attributes, I should say. The user who called the function and also the message. So you can see that here, update message. It just takes a message and then it updates the message inside the smart contract and it emits the event. So you trigger events like this with the emit keyword and then you pass in the values which you specified here. And so anytime that this function is called, there will be a record of it on the blockchain that I can go back and look at later very easily and by finding this event. So I can also get a notification anytime this function is called in real time because I can subscribe to this event externally and maybe get a push notification or something like that. So I can also get an entire history of every single time this message has been emitted. And that's another useful use case for events as well. So I should also note that these, attributes inside the event can be any data type that you want to. And you can have up to 17 of these. And you can also index up to 3 of these. So what does that mean, index? Well, in this case, we can see indexed user. So that means that I can filter through events or subscribe to events that only pertain to this particular user. So instead of getting a push notification every single time an event is called, I can filter out events that are only called with a specific address in this case. So another thing you should know about inside of Solidity is working with the native cryptocurrency of Ethereum blockchain, Ether. So you can see different expressions of Ether coded out in the smart contract right here. So Ether is divisible by 18 decimal places. So just like the US dollar is divisible by 2 decimal places, Ether has 18 zeros after the decimal place. So the smallest unit here is Wei. Another common value is Gwei, which is used to pay for gas most commonly. So you can see those in the contract. You can see shortcuts for this. 1 Wei is equal to 1. 1 Gwei is equal to this much. And 1 Ether is equal to 1 followed by 18 decimal places. You can receive Ether directly to a smart contract with the receive function if you call it external and payable. You can also use the fallback function if no receive function is implemented and if MSG or message data is not present. And inside of both of these functions, you can also implement any type of arbitrary business logic that you want. So you can see an example of here as a line that updates this count by 1. You can check the balance of any address inside of a smart contract just like this. In this case, I'm checking the contract balance address this and just calling .balance. And you can also send Ether to a different address just like this with call. Now, there are other ways to do this, but this is my preferred way because you can check for the success of this message and you can add a require statement just like this. And the last thing I'll say about Ether inside of smart contracts is that any function can receive Ether whenever the transaction is sent, as long as you use the payable modifier built into Solidity. And then you can access this value inside the function with message.value. And then also the sender with message.sender. And so speaking of this require statement right here, I'll make a quick note on error handling inside of Solidity. So we'll see 2 examples here. The most common way is to use this require statement. So this is essentially a function inside of Solidity that checks for the value is true or false. So you can see here examples just seeing if a value is greater than 10. If the value is greater than 10, then this function will succeed. And you'll see, everything after this function continue. If this value is less than 10, then this function will stop execution and this error message will be raised, okay? So another common function is the revert function. Okay, so you can see if value is less than or equal to 10, then revert, and then if it's okay, then continue on execution with the function as well. So both these 2 will get you really far. You can also define your own custom errors and use things like assert, but these will get you started. So another thing you should know about is that Solidity supports inheritance. So you can create smart contracts that inherit behavior from other smart contracts. So in this case, you can see my contract inherits from this other contract called ownable. You can see contract ownable. This basically encapsulates all the behavior of a contract that restricts function calls to the person who deployed the contract to the blockchain, or in this case, the owner. So inside the constructor, we set the owner as message sender. We store it as a state variable here. We create a custom modifier that says only the owner can call a specific function in which this modifier is applied to. So we can inherit all that behavior inside our smart contract, and with one line, we can say my contract is ownable. So you can either import this from a different file, or you can just have it in view in the same file. Okay. And then here you can see we have this ownable modifier that we can apply to this set name function. And also note that the constructor right here is going to automatically be inherited from this contract when we put it on the blockchain.